All right, good afternoon, everyone.
Good afternoon, sir.
Come on, we're about to be off and running. Two more persons, somebody else coming in. Uh, yeah, man. So here we go, off and running. Uh, so the first thing we're looking at is basically the time value of money, and just doing a quick recap because you have your test next week, Sunday. Yeah, your test is next week, Sunday. So want to know if anybody had any concerns, any areas that they weren't too comfortable with. So I'm going to be touching that. And if there were any other tutorial questions that you wanted us to touch back on, we can do that as well. But let me just go through a few basics before we throw out the questions. So the concepts that we look at for time value of money are basically our present value. All right, so present value, what something is worth now. We also look at future value, what something is worth at some prescribed time in the future, 6 years in the future, 10 years, 10 years down the road, sometime, but sometime in the future. We look at N, the number of periods. In a lot of cases, it's a number of years, but we speak more generally by saying periods because it can be what, quarters, it can be semi-annual periods, months, weeks, can be any, but as long as it's periodic. All right, so N number of periods. Then we have the rate, interest rate. I will know sometimes for the interest rate we use R or we use a K. Right, but all of those stand for the interest rate. So these are the basic variables for time value. A note at the end, payment, because for our annuities and our perpetuities, which have multiple amounts coming in, the same amount each time period, then we use the payment instead of either present value or future value, depending on what we're looking for. So I have an example here. All right, this one example says, and by the way, if you want me to, if it's too small, you can tell me. So I can no problem enlarging it. It's at what, 200% now, but in fact, let me just make this a little bigger. All right, so your parents are planning to retire in 20 years, and they would like to have $50 million when they retire. How much money do they have to save at the end of each year? So each of the next 20 years in order to achieve this goal. Given that interest rates are expected to be 10% over the period. So the first thing we do when we look at a question like this is put it in perspective. All right. We have 50 million. We need to know, is that a present value or is it a future value? So which one? Quickly.
Future.
Value.
Future value, because it's all the way down the road, way down in the future. Right? So future value. So we can jot that. Our future value, let me use red. Yeah, our future value is equal to $50 million. We have the interest rate that's given. It's
10%.
yep. We have N, which is given in years here. 20 years. All right, so given all of this, we're asked to find the payment amount, right? How much they need to save at the end of each year. So one of the first things, is this, what type of annuity is this? Is it an annuity due or an ordinary annuity?
Annuity due.
Ordinary annuity.
Right, remember now, so let me just jot both. Annuity due,
Due.
payments made at the start or beginning of each period. So if it's years, for annuity due, the payments will be made at the start of each year. But in this case, this question specifically stated that payments are made at the everybody seeing that?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, man.
So it's
So it means that
ordinary
this one is an
annuity.
ordinary annuity. Right. So note, when the question doesn't specify when the payments are made, whether they're made at the start or the end of the period, when it's not specified, what we need to do is assume that it is an ordinary annuity, right? So for annuity due, the question would have to specifically state that the payments are made at the start of the period. All right, so having that, the formula that we're using for annuity due, I'm going to use a formula, right? And I'm going to type how you would type in an exam too. Like for the final, right? Since the Blackboard Learn allows us.
Sir,
Yeah.
sir, you said we must assume, oh, it's ordinary. Okay, I see it. Never
Yeah,
mind.
man. So if, let me type it. So if it's not, if the timing then assume ordinary annuity. Right. So once the timing not stated, but in this case it's stated though. This one, it's stated that it is at the end of each period. So this one tells us definitely that this is an ordinary annuity. Right. But just generally speaking, where it's not stated, then you assume ordinary. All right. So formula. Since you are given the future value, when it comes to annuities, there's one formula for the future value and there's one formula for the present value. Because we are not given a present value, then it does not help us to write down the formula for present value, right? Because we do not have a present value to use. So because what we're given is a future value, the only formula we can write down is a future value formula. So we have future value so we have future value equal the payment amount times 1 plus I raised to the n minus 1, and all of that is divided by I. All right, so the future value, just jotting in what we have, 50 million is equal to the unknown. Here is the payment, so we'll just put back that. Open brackets. The rate is what? 10%. So 1 plus I will be 1.10 raised to the power. And the power here is 20. N is 20. Right, so 1.10 raised to the power 20 minus 1. And we divide by I, which is 10% or 0.10. Now, those who are comfortable with the table would have just gone ahead and used the table for this because the figure is there. But I want to make sure we're comfortable using the formula since there are times when you have to use it. All right, so here goes. So for those who are not comfortable with the formula, you can just work with me. Calculator time. So we'll just type it in step by step. 1.10, or you can put the 0 or not, but I'll put it 1.10 raised to the power 20 minus 1 equal. And I should say a long number, 5.7274999949. Long number. Doesn't matter because we're not writing it down. We're just going to do the next step, which is to divide by 0.1. And then we have 57.27. It's 4999. So we're going to round it off to 50. Right, so for at least 4 decimal places for accuracy. Right, if you want to use more, it will be more accurate, but we need to use at least 4 decimal places. So here I have 57.25. And then we should see the next step because we want to find the payment. So the next step would be to what? Somebody tell me what next?
Dividing each side by the 57.275.
Exactly. So divide by 57.275. So somebody work that out for me now.
It's 7,298.1230.
87,000.
872.
Yeah, no, yeah, 872.
872,981.23.
872, yeah, man, 981.23. Yeah, the 872,000 just look too enough. That's why I guess it's 87. But remember, it's annually, and this couple.
2-4, sir.
Huh?
It's 2-4.
No, man, it's 230. I'm getting
No,
2.
it would be 231. So it's 23.
Yeah, man. All right, so this is annually over the next 20 years for this couple. So not so bad if you divide it by months, divide it by 12. So they need to work on at least 72,750 thereabouts per month. Right? If they are doing it monthly, of course, it wouldn't be what we just did. It would be a little different. Because if you're compounding monthly, you're getting more interest. So the calculation will be different.
So a question.
Yeah.
How would you advise us to punch in these figures in the calculator?
No, man, just like I just did. So let me go through it again.
Yes, please. Thanks.
Just one by one, step by step. We start with the first part. 1.10 raised to the power 20 minus 1 equal. So solve the top part, then just divide by 0.1. And you should see the 57.27499999949.
All right, sorry, when I did that, it said some error, so I'm going to try again.
You said error. What kind of calculator you have?
The Casio.
All right.
Trying to
And what
put
you use for the power? The little
the
arrow?
yes, the arrow looking up, that the raise
All right.
thing what you have there.
All right. So do this for me. Put the 1.1 raised to the power
Okay,
20
1.10
Yeah, raised to the power 20
20. Yes, sir.
equal.
Okay, I get
All right.
6.7274.
Yeah, man. So you can break it that way. Then subtract 1 minus 1
Okay.
equal.
Yeah, I get the 5.72.
Yeah. And then now you
Yeah.
divide by 0.1.
All right. Thank you, sir.
Yeah, man. No problem.
I get the 57.74994. Yeah. Yes, sir. Thanks.
Yeah, man. Right. So what happened now is that you realize that even though we're doing the formula, it really not that long if we basically punch it in like how we're doing it. So yeah, Shauna.
Sir,
Or you had a question, Shauna, or
yes, sir.
yeah, man, go ahead.
Where you have the 1.10, I know where you get the 10
Yeah.
and the 20, but where do you get the 1.10 from? The one in front of the 1.0, the 10.
Oh, right here. Because remember this is 1 plus the 10% in the formula.
Oh, the formula that you're using.
Yeah, man. All I'm doing is just filling in the unknown, filling in what's given and solving for the unknown.
So, sir, is that the ordinary formula?
Yeah, man. This is the ordinary annuity formula. The annuity due formula at the end, you'd have multiply by 1 plus I.
I'm seeing something different on the lecture sheet where it says the future value equals the present value bracket future value interest factor annuity bracket with the interest and the interest and the number of years. Would we be using that if we're using just the table?
If
What's
you're
the
using the
difference?
table, it still wouldn't be present value. Using the table, it would have said, because remember, present value is where, when you have future value and present value, it's where you're dealing with a lump sum, a single payment. So when you're dealing with a stream of payments, we say payment instead.
So you can repeat
I
that
don't
again?
understand that.
All right. Note, when you the formula that says, all right, let me put the correct formula first. The formula would be times future value interest factor annuity, I, comma N, comma on I. Yeah, so what I was saying is,
That's not what I have, sir.
you're seeing it on my slides?
Oh, yes. Oh, yes, sir. That's it.
That's it, right? Yeah, man. So
Yeah, that
this
is
is
it. So I
just,
wanted to know what's the difference.
no, the difference is just that this part, all right, look on the tables. Look on let me pull up the tables. So in this case, all right, so let me use this. 50 million equal payment times, and in this case, the interest rate, let me put them up here. The rate would be 10% and N is 20 years. Let me just put 20. All right, so you're going to look at the future value annuity table. for 10% and n equal 20. I'm gonna pull up my table in a second. Just gonna make it a little bigger. All right, yeah, see it here now. New share. All right, so this is my table, right? I have this in Excel here. So 4 tables. This one is not it. This one says present value, interest factor, lump sum. So at the top of this, I would have put present value lump sum. Right? Not the one I want, because I want the future value annuity table. Scroll down. This one says present value interest factor annuity. Still not the one I want, but I'll still just label it PV. PV annuity. All right, scroll down some more. Future value, interest factor, lump sum, closer, but not the one. So I'll label future value. And these labeling just make it easier for me to pick up the right table. All right, so there's only one more leave, so I know it must be that one. So future value interest factor annuity, FV. FV annuity. All right, so I'm looking for 2 things. I'm looking for interest rate. The interest rates are at the top. Notice it says K%. Go straight across. By the way, it also shows you the formula up here. But they use K instead of I. Right? And this is, the tables are only for the ordinary annuity. So I want interest rate 10%. So interest rate 10% and n equal 20. I mean, it's a little bigger. Yeah, so n equal 20. So I'm basically going across in the 20 row to where I get to 10. And you notice that figure, Shauna?
Yes, sir.
It's the same figure that we worked out.
Right, sir. So I was saying in like, for instance, we're doing the multiple choice.
Yeah?
The other formula wouldn't have been too long, sir.
No, man, no, it doesn't take long enough. The point I'm saying, Shauna, for this one, you could have just used a table. It would have been a little shorter. A little shorter, not no big difference, right? Because as I show you using the formula, if you use it correctly, it doesn't take a whole lot of time. But why I'm using the formula is that there are some cases where you're not able to use a table because the figures would not be on the table.
The years would not be on the table.
Either the year or the rate, not on the table.
So
So in those cases,
it's
you
possible
have
for
no
us to get
choice. You have
something
to
like
use the
that in
formula.
the multiple choice second test.
Go again.
Possible for us to get one of that in the second test.
Yeah, man, it's possible. It's possible. It's always possible. The issue is, so I'm saying most times you're able to use the table, but there are a few times when you might not. So I'm saying just the formula is really not difficult. So just get used to it as well. That's always we're saying.
Okay, so with this formula now, you would just with the years given, you would just look for the years and the interest, and then you divide it by the 50,000.
Right. It takes you to this step.
Okay, sir. Thanks, sir.
Let me go back to it. Sure. Yeah. So it basically takes you to this step.
Okay. So, sir, annuity, the ordinary annuity formula and the annuity due formula is different.
Yeah, man.
Or is it the same?
No, it's different. The difference is just that at the end, For the annuity due formula, you multiply by 1 plus I.
For the annuity due formula,
Yeah, at the end, you have multiply by 1 plus I.
plus
So everything else is the same. So if this was an annuity due, you'd have had if this was an
would
annuity
be
due,
the F.
yeah, you'd have had FV equal payment times in bracket 1 plus I to the n minus 1, right, close that brackets, divide by I, and then at the end you'd have multiplied by 1 plus I. I can probably let me put some more brackets. Well, basically at the end of it. Let's use a bracket to separate this.
Okay, that's
Right, so it's almost the same, except that look at the two formulas. All that's different is this part at the end.
that part at the end. So,
Yeah, one
sir, with
1
the
plus I.
tables,
For the tables,
mhm,
same principle. You would have said future value equal payment times FVI FA, FVI FA, I comma N, right? Then you have multiply by seeing it now?
Sir,
Uh-huh.
for this 50 million, the third line,
1, 2, 3. That's here.
isn't the formula future value annuity equal payments with the future value of the factor annuity, interest, number of period, close bracket, open bracket, also 1 plus interest?
Say that again. Say that again.
I think, yeah, that line. You leave off the 1 plus the interest. Where's the interest part?
The 1 plus interest at the end.
Yeah,
No
because
man,
one.
remember this is not an annuity do you know.
Oh, so it's 1 minus.
No man. Watch me. For the ordinary annuity, let me just put that formula. I'm gonna copy it just because I'm just gonna delete the part that doesn't apply. So these are the formulas. All right, so I'm saying what's different about them is that for the annuity due, you multiply by 1 plus I, 1 plus the interest rate. The question we just did was not an annuity due, it was an ordinary annuity. Right? Why we know it's an ordinary annuity? Because payments are to be made at the end of each period, end of each year. So this one did not have 1 plus I because it was an ordinary annuity. You seeing it, Tisan?
Yes, sir. I'm writing it down in order to remember.
All right.
Thanks.
Yeah, man. Once you know your ordinary annuity approach, you just know that for the annuity do is just multiply by 1 plus I.
Sir,
Yeah.
but I see for the annuity due formula that I'm looking at here, isn't that divide? That's a division sign, right?
Where?
That slash there for the annuity due formula.
No, it's the same slash. Let me highlight this. This slash you're talking.
Yes, sir. The one for the formula that says annuity due in black.
Mm-hmm.
Yes, I see that slash. That's
Which
a
one? This?
division sign. Yeah, that's a division
Yeah,
sign,
man.
right?
But look at the one below it.
So what it's basically saying is that we're dividing it by the interest. However,
Yeah,
for the
man.
annuity due, we're multiplying it by 1 plus the interest.
Yeah,
So
but once
both
it's an annuity,
formulas
you
have the
divide by the
divide
interest.
by the interest.
Yeah, once it's an
Okay.
annuity, you divide by the interest. All the annuity formulas. Yeah, handle.
Okay.
Yes, sir. So for the annuity due, in using the table, you would find the corresponding value, and then you multiply it by the 1 plus I.
Yeah, man. All right, let's do an annuity due example. I'm just gonna copy the question here. I'm gonna change it a little bit, but to make it an annuity due. All right, so your parents are planning to retire in 20 years. All right, so this time it's Handel parents. So Handel parents can't live off of 50 million. Handel parents want 80 million. All right. How much money do they have to save at the start? Oh, I'm going to change this one completely. Start of each month. All right, so your parents are planning to retire in 20 years. Right, and we have some fun with this one. All right, so retire in 20 years. I would like to have $80 million when they retire. How much money do they have to have at the start of each month in order to achieve this goal? So now we're working with months, not years. Right, so we see it's an annuity due, but we're working with months. So this is what we're going to do. A couple things. What's the periodic rate? Anybody, what's the periodic rate? Or the monthly rate?
It's 12%.
12%, sir.
No, the
12
12% is
divided
the annual
by,
rate, the nominal rate. So let me drop that above. So the nominal rate
that's 1%.
equal 12%. So the monthly rate, right, is 1%. 12% divided by 12, because it's 12 months, equal 1%. Right, so nominal rate, 12%, but that's for the whole year. The monthly rate or the periodic rate is 1%. Let me push all of this down to the next page. 1%. Yeah. So, so let's jot down the basics. The future value is 80 million. So N now, it's 20 years, but it's months that we're working with. So how many months we have in this 20 years?
12 times 20, sir.
140 months.
Yeah, so 12 times 20, 240. Sorry, 1 minute, guys. I'm not sure if this is somebody related to the class. I call coming in. 1 sec. Oh, the person went. It's all right. All right, so N is 240. What else we have? We have that it's an annuity due. It's an annuity due since the payments are at the start of each month. So we have the rate, we have the number of periods, we have the future value. So, all right, so using the tables, we would say future value equal the payment times future value interest factor annuity, I, comma, N, right? And because it's an annuity due, we multiply by 1 plus I. So jump putting in what we have. Future value is 80 million. We don't know the payment, so we can leave that as PMT times, just going to jot this, future value interest factor annuity for 1%, comma, 240 for N. And all of that is multiplied by 1 plus I, which is 1.01. So now we're going to go to our future value table and see if we can find that. All right, so let me switch the view. All right, so now we're looking at 1%. Let me clear what we had before. All right, so now we're looking at 1%. I want N equal 240, so we're scrolling down. And unfortunately, it stops at 60. So what we're saying is for this one, we can't use the table. Everybody seeing that?
Yes, sir.
Yes, sir.
So what we're going to do is switch to the formula then.
Sir, question.
Uh-huh.
Whether we're using the annuity due or the ordinary annuity, it's the same table, right?
Yeah, man.
For annuity.
Yeah, man. The table is
Okay.
only for the ordinary annuity. That's why
Okay.
when you look for the factor, we'd have multiplied it by 1 plus I because it's an annuity due.
Okay, okay.
Yeah, man. All right, so payment, I'm using the formula now. So use my curly bracket first, then my squarish bracket. So
We're
one.
not seeing one, the curly bracket.
Yes, sir. We see the table.
Sorry, go again.
We're seeing the table.
I didn't hear that.
Remove the table. We're not seeing what you're typing.
We're seeing the table.
Oh, yeah. Sorry about that. Sorry about that. All right, so here we go. Back to the Word document. Yeah. So payment times 1 plus I. We'll put the formula first. So 1 plus I raised to the n minus 1 divided by I. right? And then we multiply by 1 plus I. So that's not the formula. All right, so filling in the blanks now. 80 million equal payment times the 1 plus I is 1.01 because I is 1%. Raised to the N is 240. Then we have minus 1. Divided by I, which is 0.01. Close brackets. Multiplied by 1 plus I, 1 plus 1%, 1.01. Now, once you have the formula correctly, put in the variables correctly, let's go through the calculation very quickly. It's almost at the time to take it to look for it on the table. Right, so calculator up. I'll go in step by step. So clear calculator, 1.01 raised to the power 240 equal, right? So get something like 10.89 something, right? Subtract 1.
It would be 10.89255.
Right. Then subtract 1.
9.89255.
Right. Then divide by I, so divide by 0.01. Okay, so I should have 989.2553654.
Yes, sir.
Right, then last step, multiply by 1.01. And that gives me
0.1479.
1479. Yeah, man, keeping the 4 decimals. All right, so just did it slowly, and as I said, it really doesn't take that long. So the last step now, we're back to simple and 80 million divided by 999.1479 gives us the payment. So the monthly payment,
80,068.
say it again.
$80,068, 23 cents.
80,068.
68.
Is 2 decimal places you must use or 3?
Yeah, when it comes to the final answer, you can use 2 decimals.
Okay, good.
All right, so this one a little bit more technical because we switch it to months. Yeah, most of what you're getting, I don't think even when you something like this, but principles are principles, and I wanted to understand the principles. That's a goal. All right, so what I want now, I just went through 2 types of annuities. I'm gonna switch gears now, and I'm asking everybody, is there any question on the tutorial sheet that still has you puzzled? Before we jump, we're not going to stay long enough. It's about 2 hours till it, or a little less. I want to start touching base. I'm going to touch on the bond valuation. But before I go, I just want to make sure we throw it out. Is there anything on the tutorial sheet for time value of money that you're uncomfortable with?
Sir, bond valuation is unit 5, right?
Yeah, man, the next unit, unit 5.
We're getting tests on that, tested on that for unit 2, test 2?
But life continues. Remember, I know the semester going fast, you know.
Oh,
But
okay. I thought we were just trying to concentrate on what we're being tested on, but no problem.
No, right. We concentrate on that first. That's why we do that first.
So scroll up back to the first lesson. Let me see what. All right, sir. Thanks.
Yeah, man. That's why I wouldn't do this class next week because I wouldn't want to be
Sir,
touching
don't
on
change it as yet, please.
Go back to the first one.
Yeah.
All right. Yeah, and while they're writing, guys, as I said, is there anything on the tutorial sheet that you're uncomfortable with? Sometimes you kind of see the answer, but you're still kind of doubtful about exactly why we did a certain thing or so forth.
So you can go back up and trying to capture the ordinary.
This one was the ordinary. This one was the ordinary annuity. The one below is the annuity due.
Sir, for the two formulas, when all right, for the first one, annuity due on the left,
Yeah.
when do we use that one?
What is an annuity due?
No, man, I know it is when one is at the beginning and one is at the end or the starting.
Come on, the annuity due is which one?
I remember.
See it right on the screen there, so look up top.
Where? Oh, lovely. It's all right. Annuity due is at the beginning.
Right.
But I see you have two formulas, or the two of them is the same.
Two of them are same.
Okay. Oh, them just kind of different.
Yeah, man. Somebody asked how would they approach it if we were using the table. So.
And one is for the calculator.
Yeah, man. Over here, so is.
Okay, cool. Lovely. Understand.
Sir, will any of the questions asked if you use the table specifically or
No, man, no.
You just use any one you're comfortable with?
Right. We don't tell you which one to use.
Sir, for the calculator for both formulas, those brackets are needed?
They basically make it complete here, in a sense.
Okay.
Normally, no. This is what the formula looks like. Let me show you what it looks like. I do it like this because if you're typing something, but I guess you would be typing for this. You'd be writing rough, not for submission. So let me show you what. Let me draw. Yeah, so the formula really looks like this. And that's what the formula looks like.
Okay.
And sir.
I remember the present value formulas are different, right? But you have them on the slides, you know, so you have the formulas on the slides. So one of the things I suggest, coming Shauna, one of the things I suggest, guys, just put together your formulas. Just have them in the same place so you don't have to go all over the place and looking for formulas. All right, Shauna.
Sir, you said for the calculator formula, that one is when you don't get the years or the interest. That one is when the years or the interest is not presented on the table, right?
No, but you can use it anytime, but if the years and the interest are not presented, you have no choice but to use it. You have to use it.
But sir, for multiple choice, I wouldn't choose this one on the left.
No, man, because you don't like formulas. Not true?
Because sir, the amount of time that we get by the time we're finished doing this, it will be time would have passed by a lot of time.
All right, watch me now. I'm gonna challenge you now. I'm gonna challenge you right now. You hear? You taking the challenge?
Okay. Yes,
I'm gonna
sir.
put two things on the table on the board. All right, I'm gonna copy boards. Don't cheat, you know.
So what am I supposed to do?
Soon tell you, man. I don't have it there yet. All right, so this is what we're solving. We're solving this question. I'm using the calculator on the left, and you're using the table on the right, right?
Sir.
So ready? We're going now after 3. 1, 2, 3.
But you're a pro at this, you know.
No, but I'm not going very fast. I'm going regular speed. I even pausing to pretend I'm not sure what to do next.
Sir, it's just for her or everybody?
No, man, just for her. Everybody can do it, sir. Anybody can do it, man.
Okay, sir. Sir, can tell her the answer too?
Huh? No, man, let's work it, and then the main thing is this part. It's just I'm just showing that even though I'm doing this very slow.
Sir, I did it long time.
Using what?
The table.
Yeah, man, but
Yeah, man, say table quick and fast. I'm done already.
That means that,
Don't worry, put out the figure.
Just remember, say nobody. Remember, say with the calculator now work on a day there.
no, but watch me now. You see it now on the sheet, you know. Me go very slow for pretend to me a student. On the cheating on me.
No.
I said the hardest part of the table, you have to find which table to use.
Yeah, man, watch
Yes,
me.
sir. That's all.
Hey, hear me now, Andel? I
Yes,
can tell you, say, enough people under pressure.
Choose the wrong table.
Yeah.
Yes,
So
sir.
what's
No, man. Notice what I showed you to do with the tables, you know. I'm showing you the right way to approach everything. You notice that what I did with my tables, I label them.
So you would get the 690.2 or 3?
Yeah. No, man, it's not even about the final answer, but let me check. It's about just a figure.
Sir, I would definitely use the table. Like, no doubt about that.
If sir put the something then with the tape.
No, man, what about questions, man? What about questions?
Sir, the formulas are for professionals, not for students.
Who said that again? Shauna?
No, sir, I'm saying
no,
the calculator formula is for professionals.
No,
It's not for professional. It's for when you have time.
Exactly, because 20 multiple choice in 1 hour, like.
No. You guys watch me again. Let me show you something. The question come up. I see all of this. How long does it take to type this in the calculator? Why am I going slow?
Sir, you need to remember, not everybody calculator can do that little something there up at the top, that little something there.
Every calculator that is scientific can do it.
That sharp here scientific, but it's not scientific enough.
No man, once it's scientific, it's either it have the little hat, the Casios have the little hat looking sign, something that looks like this. The Casios have that. Yeah, that look more like upside down V.
Sir, as long as the figure can find on the table, I'm not going to work it this
No
way.
man, I don't have a problem, you know. Don't get me wrong, you know, but I'm saying to you, on the talking like the formulas are hard, and they are not hard, they are very simple. The table will be faster, of course.
They are okay, but it's time consuming.
No, but not really with practice. You see, everything in life, you know, is practice. You see, when I just learn to drive a car, it takes it forever to move from point A to point B. Why? Because you're afraid.
Yes, sir. But remember, we're only doing it for like a couple of weeks. Unlike you will be doing like for a long
Still
time.
try to find the indicator on a car here.
What's you know? Young, fresh green brains on a sharp like a razor. On your pretend on a dull.
No, the thing is, you know, sir, sometimes in exams, some persons tend to get nervous and flustered.
That's the same thing with driving. You know what makes the difference? You know what makes a big difference? Practice, practice, practice. The more you practice, and sorry, there's this thing that they talk about. I'm going to leave this still now, because don't get me wrong. I'm not telling you to use a formula. I'm just telling you that you should not be afraid of the formula. So I don't want the wrong message go across. Right? What I'm getting from a lot of people is that they're kind of afraid of the formula. And I'm saying you shouldn't be. It's just practice, 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 nothing else. You see this, yes, you know why people get nervous in exam? Fear. You know where the fear thing come from? Self-doubt. You see, if we can get over this self-doubt thing and stop doubting and just believe, so listen, you know, my thing that I tell myself, you know, and I do it based on the scriptures. It's I can do all things through Christ who gives me strength.
Yeah, man, sir. Remember, self-doubt come with time, you know. It not come with a few weeks between exam.
But guess what? No, but watch me now. It will never go away until you take a conscious decision that you're going to get rid of it.
So true.
It's not going to go away same day, no. And you're friend for some people go quick. You get over it very quickly. Some persons will take a little more time, but you make a decision that I'm going to stop doubting myself. And when I feel like I'm doubting myself, I remind myself, so listen, stop this foolishness. I can do all of this thing. None of this thing no bigger than me. People have done it before. I can do it too. You understand? But it's a decision you have to take that you're going to stop doubt yourself. All right. So I'm going to move on still. Because I said my message is not that you must use the formula. That's not the message. Don't get me wrong. Right? If I have for me, I'll use either one. Don't really matter to me. But the formula is, the table is quicker. That much I can say without hesitation. All right, but don't be afraid of the formulas. It's just numbers to plug into a calculator. Nothing really way out. All right, but going back now though. So I'm saying, going back to the tutorials questions. Any one of them have any are uncomfortable? Any part of any question?
Sir, can you do 12?
Which one?
Can you go back number 12 for me, please?
All right, hold on. Let me look for it. Oh, what are things happening in the chat? I'm going to turn off my chat. Hold on, let me just see.
I remember I was telling you that was a tricky one with the semi-annual compounding.
All right, but they bring up all the tricks, man, the tricks and the trade.
The one there always.
All right, so let me bring up this now. Question 12. Let me make this a little bigger. All right, so question 12 says, Oh, yeah, I know this one give a lot of people a little headache. All right, let me not do it over here, so I'll go back to my, I'm just copying it. I'm gonna go back to my working document. Make this bigger. All right, so this is tutorial sheet 4, question 12. All right, so it is now January 1, 2001. You plan to make 5 deposits of $100 each, one every 6 months. So just to put it in perspective, let me just draw this little timeline thing. So I was supposed to be a straight line, but not really matter. So we have January 1, 2001. Six months later would go July 1. So July 2001. 6 months later, January 2002. 6 months later, July 2002. And it's here making 5 deposits. So this is 1, 2, 3, 4. So one more. And this one would be January 03. So 5 deposits. And each of these is 100. Right, so from this we can see the N is, for this annuity, it's an annuity due. It's an annuity due. Everybody can tell me why I said due?
So it says deposits every 6 months.
Every 6 months.
No, not just that, because you plan to make the first payment when?
Yeah, first
At the
payment.
start of the year.
Yeah. So the first payment today, so it's at the start of it's the start of every 6 months you're making the payments. So once it's the beginning of the period, it's the annuity due. All right, so annuity due with N equal 5. Okay, almost like N is the number of payments, which is 5. I push this down. So we're on one page. All right, so N is the number of payments, which is 5. Yeah. The nominal rate is the rate that they gave us, which is 12%. But it's every 6 months. So we're working with semi-annual periods instead of years. So the semi-annual the periodic rate or the semi-annual rate is equal to what?
Sir.
Is it 6%, sir?
Yeah, man. Remember the semi-annual rate is divided by the number of compounding periods.
So it's 12 divided by 2.
Yeah, man. So 12% over 2 give us 6%, right? So we have that. N is 5, the rate is 6%. Now, annuity due, let me just put another tick here. I'll call this July. Because what the formula is going to do, it's going to give us the future value at the end of, because we're using n equal 5, it's going to give us the future value at the end of 5 periods.
Right, but you'd want it for the starting of the next period.
Yeah. So, no, but just counting the end of 5 periods. So 1 period in here, second period in here. In fact, what I'm doing now, you even can ignore all of that technically if you see it another way. But we are going to find the future value at this point. Right? You don't really need everything that I'm showing now, including the timeline. Not really needed. What first thing for you to see is that you're making 5 deposits. It's $100 each. It's every 6 months. So it's semi-annual. Once you say every 6 months, you know it's semi-annual. And the first payment is today. So you know it's an annuity due. Right? So that gives you everything that you need. So let's find the future value. So future value, I'm going to use a table. So future value equal, the payment is 100 times future value interest factor annuity. And the rate to set is 6%. And N is 5. So let's put that on the table for me, please. 6%, N is 5.
Or 5.6371.
Yes, that's what I got.
Yeah, man. See it here. All right, so yeah, correct. 5.6371 is correct. So 100 times 5.6371. Yes, go ahead.
Never mind.
Right. So what this is saying, so I'm not going to really go far with what I was doing up top. I don't want to confuse persons. God, this is I was going a bit deeper down where it is, but you don't need to go that deep. If I go through it and you're still not seeing it, then I'll go through the deeper explanation. Because some persons kind of want to see it, to see the deeper picture, to get it fully. Right? So this future value at the end of 5 periods is 563.71. But the question says, how much will they have in their account after? How much will they have in their account after 10 years? So this is after 5 semi-annual periods, not even 5 years. 5 semi-annual is like 2.5 years. All right? So what we want to say is N equal ouch, 7.1. So 10 years.
I'm sorry, the figure with the 563, that's the first semi-annual payment, right?
No, man, that's a future value. So all of these 100, 100, 100, 100 with interest add up to 563.71.
Oh, that would be the first payout.
No, you're not. No, man, no payout. Remember, you're not getting the money back now, you know.
Okay.
What you're doing, just picture it. It's a bank you're depositing money in, right?
Yes, sir.
So you have some money now, but you're not going to have any money after that. You get a special contract now that gives you some money that you want to save. It's a 2.5 year contract. That gives you $100 at the start of each period. So you try and get the $100, you say, here what, I'm just gonna bank it. I want to see what this thing can do for me in 10 years. So January 1, 2001, straight to the bank. July 1 to the bank. January 1, 02 to the bank. July 02 to the bank. January 03, the last payment to the bank. At the end of 5 periods, the future value there, so with interest, it accumulates to you. This is what you have in your bank account, $563.71.
Okay.
So if you were to draw the money out at that point, that's the amount of money you could take. But you're not touching the money, you're leaving it because you don't want it until 10 years' time.
So, sir, it's basically after you deposit the 5, after you make the 5 deposits each time, right, sir? That's the
Right.
total. Okay.
With interest, the total with interest.
Okay. All right.
Yeah, man. So you want to
Okay,
say
what were
no?
you saying about the 10 years?
Right. So the issue now is this. We're not going to touch this money here. We're going to leave it for, we want it to stay for the full 10 years. So this is what we're saying. After 2.5 years, total accumulated, the total in our bank account is 563.71. We're not going to deposit any more money. We want to find out now, we're leaving this money for the full 10-year period. How much longer are we going to leave it for?
Sir, can you repeat the question?
Right. So this is in investments, in finance, we call this our investment horizon. It's 10 years. After 2.5 years, the money reached 563.71. But 10 years don't finish it. How much longer we have to reach 10 years?
We still have 7.5.
7.5 years.
So still have 7.5 years left to reach the full 10-year horizon. But at this point, we're not doing any more deposits. So it's not going to be an annuity going forward. It's just a lump sum now going forward. We have 563.71 in our bank account, and we're leaving it for another 7.5 years.
So, sir, for the remainder of the 7.5 years, we won't be making any payments.
No, we're not doing any more deposits because notice it says you plan to make just 5 deposits of $100.
Okay.
So we're not doing any more deposits.
To get that, what we do now is use the present value plus the interest factor.
Right, present value times the interest factor.
Okay.
But so what we're saying is, because we're working in semi-annual periods, 7.5 years would be 7.5 times 2. Not true?
So times 2 are divided.
No man, times. If it's two of them every year. If you get 2 mango every year for 7.5 years, how much mangoes you get? It's mango season, so I use mango.
And you did multiply it.
Yeah, man. Yeah, Handel?
Sir, question. So since it's the annuity due and we use the table, we should have multiply by the interest rate plus 1.
Yeah, that part was left off.
Right. I'm glad somebody see it.
No, sir, I saw it, but I was thinking that you were doing it without the interest that it earned before.
Oh, no, man. Because it's an annuity due, if we're doing the correct thing,
you just have to add
multiply
it
by 1 plus I.
Yes, sir.
So in total, you should get 597.
All right. Yeah, man. So on on the ball. So
Right.
one, we just add the time 1 plus I. So all of this times 1.06.
06.
So tell me the figure.
597.53.
So let me correct this to 597.
So, sir, in essence, you just worked out the ordinary first, and then you just added on the 1 plus I.
Correct, yeah.
Right.
That's the only difference between them, you know. The only
Understand.
difference between the ordinary and the due is the 1 plus I. The due give you a little bit more interest. That's what they're saying. If you put your money earlier, remember now, if you put your money at the start of the period, you're going to get a little bit more interest. That little bit more interest is the 1 plus I.
Sir,
Uh-huh.
but didn't it say how much will be in your account after 10 years?
Yeah, man. That's why we're getting to next. So we're saying after 2.5 years, we have $597.53 in the account.
So, sir, if you were using the formula, the formula would only give you the 597.53?
Yeah, man, same thing. Same principle. See, so if you're using the formula, it's the same answer you should get up to that point.
Oh, sir, when you work out this semi-annual into the 5 years, that's how much you get.
Into the 5 payments, yeah, not years.
Well, I'm looking on the end that says 5.
Yeah, but don't say years, guys, it's not years. That's what I put. I need to deal with N, where N is equal to
Number of payments. Oh,
yeah, man.
okay.
So don't say 5 years. It's not 5 years. It's really 2.5 years.
So, sir, if you were using the formula, where n is in the formula, we would have to put we couldn't put the 5, sir.
Yeah, man, same thing. All right, let me show you. Using
Yeah, you would still use the 5.
yeah, man. So let me show you.
Because it would be the 2.5 times 2.
So we would have future value equal $100 times. So the one would be 1.06 raised to the power 5 minus 1 all divided by 0.06. And then at the end we have times 1.06. All right, so what you'd have is working in the brackets, we have 1.06 raised to the power 5 equal 1.33822, some whole part numbers, minus 1, I get 0.33822, divide by 0.06, I get 5.63709, and then I multiply by 1.06, and that gives me 5.975318538, and I multiply by the 100, which gives me 597.53. All right, so it will be the same up to this point. There will be no difference in the answer that we have here, because we're saying the future value of the annuity due is 597.53. And that's after 2.5 years. So for the remaining part now, right? 7.5 more years.
So we get it 2.5 years.
2.5 years. So 6 months. So count with me. January 1, 6 months.
Yes, sir.
Plus 6 months is 12.
Oh, okay, okay.
Plus 6 months.
Mm-hmm.
Plus 6 months is 24. That is 2. Plus another 6 months. Reach 2.5 years.
Okay.
Yeah, man. So that's what we have. So 5 payments, but it's half year each payment, 6 months periods. So it comes to 2.5 years. So 2.5 years gone, we have 7.5 years left. We can do it the way we said the future value. Equal the present value, 597.53 times 1 plus the nominal rate, 0.12 over 2 raised to the 7.5 times 2. This formula is this one. When you have more frequent compounding, yeah, that's the formula we're using.
Sir, that's why I didn't understand, because when I was working the question, I initially started with that formula. I didn't know that, yeah, I didn't know that I had to work this part first.
Yeah, man. Cause remember now, the first thing that you have is the annuity due. So you have to take care of that first before you move on to what happens after.
Yes, sir.
Sir.
Yeah.
Remind me again what the 2 represents in the bottom formula.
Here, the M is the number of compounding periods. So because it's half year or semi-annual, it means you're compounding 2 times for the year, every 6 months. So two times for the year.
Okay, sir.
Yeah, man. All right, you guys have the answer already still, but somebody can tell me again.
$1,400 hold on, let me double check.
1,432.02.
432.02.
Yeah, 1,432.02. All right, so it's what 6:37 now. What I'm gonna do, I'm gonna push forward. What I'm gonna say to for the persons who still have things that they're unsure about and they want to ask question, you can reach out to me. If you send a WhatsApp message, yeah, try and respond. Send a WhatsApp message or email. If you call me and don't get me, don't leave a voice message. I don't really listen to those things. Right. So if you call and don't get me, send me a WhatsApp or send me a regular text message. So I know who called and I can respond. All right. So remember the voice message thing. I normally check those like probably 1 week after, like one. In fact, I get the notifications late, but I normally check them probably 1 week or so on after I see those after they come in. So don't bother leaving it. It's a waste of time. So email, if you call and don't get me, email or WhatsApp. All right. So I'm gonna touch with the bond valuation. I know persons don't really start studying it yet, but yeah, I want to start the sensitization because we're doing this tutorial come next week. All right. So the principles, just basic principles I want to go into before I look at the question. This question is from a past paper because I'm not touching the tutorial questions at all. But you realize that it's very similar to tutorial questions. All right. So principles. The value, this is an essential principle to get. The value of a bond is the present value of the remaining payments. That is from now until the end. Always ignore all right, I said always ignore the past. Also, soon try to make that more clear. So when it comes to a bond, and there are many videos on the bond, we have some in the, let me check something quickly. I think I'd put the video there. Just want to make sure.
Yes, sir. Videos are there.
Huh?
Yeah, man. I think two videos are there after the tutorial, after the lecture.
All right, yeah, man. Those right. So those should explain. I just want to make sure it's the right one I have there. I'm going there quickly now. Oh yeah, right below the lecture. Yeah, man. So please watch them on the bonds. It's some of them they kind of, they're not too long still, and I don't think they're really bored. I try to find some that not so boring. Easier to listen to than me. Right? And they're very practical. So watch the videos. So I'm not going to go over what they have in the videos. Right? But what they do in the videos is explain how bonds work and what they are and so forth, and put some context to the whole bond thing. All right, so well, let's look at these questions. So this one says, John's company has taken advantage of the prevailing low interest rate environment to raise new financing. Blah, blah, blah. It issued bonds. So so here read something important now. Let me underline. It issued bonds on January 1. All right, should we write?
So technology still same way, even in a test.
But no, but so fix it. Important thing is don't panic. Don't panic. All right, so it issued bonds on January 1, 2008. Right, so the issue date is important. Issue date is January 1, 2008. All right, continue now. It also said they mature on December 31st, 2030. So in this case, they did not tell you the length of time for the bonds. They didn't tell you how many years. They just told you that it starts January 1, 2008, and it matures December 31st, 2030. Now, there are some, in some cases, you have to find the maturity date for yourself. So what I wanted to tell me is how many years this bond was issued for. How many years from 2008 to 2030?
Sure, 22 years.
Yeah, I know somebody going to say 22, which is
Oh,
wrong.
sir, it's 21, 23.
Yeah, man, 23.
23.
Yeah.
So watch me now, guys. There is a trick with this. You're tempted to say, you're tempted. Let me put temptation because.
Sir, would the 22 stop at January 1st and then the added one would go to December 31st?
Right.
Yeah, so that's 23.
Yeah, but I was showing person's tempted to say this equal 22. That's a temptation. But that would be from, when it says subtract 2008, it means you're not counting 2008. Because you're saying subtract 2008 and before. Everybody with me?
Yes, sir.
Worst case when it comes to these questions, it look basic, it look junior, it look primary schoolish, but it doesn't fail. Count on your finger. 2008, 08, 09, 10, 11, 12, 13, 14, 15, 16, 17, that are 10. Start over. 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, that are 20, 28, 29, 30, that are 23 years. I realized that didn't take 1 minute. Right? So it's primary schoolish, but you can always do it to just double check. Because under pressure, as I say, you might do the wrong thing, and you want to make sure, because if you choose the wrong figures, your calculations are going to be wrong. So always, you can just do that backup check quick. Don't take much time. Yeah, man, just count on the fingers. All right, so it's really 2030 minus what is not to be counted. Right, so from 2007 on before that is ignored. So we're subtracting that. So it's a 23-year bond. So the question could have said, instead of telling you the maturity date, the question could have said, it issued the bonds on January 1, 2008, and the term of the bonds is 23 years. That would require you now to find the maturity date for yourself, right? So be comfortable doing that too, right? And just note again that you wouldn't say, you
Sir,
wouldn't
not
just say
to cut you.
2008 plus 23. You'll get it wrong. That would be 31, and that would be wrong.
But if they had left it at January 1st, 2030, it would have been the 22, right?
Yeah, man. Sorry, okay. I wouldn't have said January 1st, 2030, because the maturity date, January 1st, basically step over, is the beginning of a new year. So the bond wouldn't reach January 1st any at all. It would always be December in this case.
Okay.
But when it comes to the valuation now, that's where that part comes in. All right, so let's look at the question now. First thing, coupon rate. The coupon rate coupon rate gives you the periodic interest payments. And it's a periodic because the common things are either annually or semi-annually. Most common is semi-annually, right? So half year. So the coupon rate here is 6%. The par value equal $1,000. Now, this is normally the case. So even if the question doesn't tell you the par value, you'd assume that it's $1,000, right? So the only way you use another par value is if the question gives you a separate par value, right? So the par value is always $1,000 unless you are told otherwise. All right, par value, $1,000 unless you are told that it is something else. All right, so continuing. What this is saying is that the coupon payment, which is what we call, what is our interest payment, is equal to 6% of 1,000. We always multiply the coupon rate by the par value. So 6% of 1,000 is what? 60? Yeah, $60. And that is per year. So this is saying every year you're going to get $60 in interest payment, every year. But the question says that coupons payments are made semi-annually. Everybody see that? But they gone quiet on me, man. We soon finishing up. Just about another
Yes, sir,
15 minutes or so.
See. Sir, we are
Able
here, yes, sir.
by 2. Sir, we are trying to focus. That's why we not talk while they talk.
Focus,
All
right, and listen.
Yeah.
All right. Cool. All right. So every year you're getting $60 in interest payments. But it tells us that they are made semi-annually. That means, let me just type it. So coupons, it says coupon payments are made semi-annually, meaning 2 times per year. Technically, what that means is they split the payment in 2 payments. So it's $60 per year, and you chop it down the middle. You split it in 2. So the semi-annual coupon payment is equal to half. I'm just to divide by 2. So $60 divided by 2 are $30. Let's make a note. It's like we can say that now written in stone. Every 6 months, every semi-annual period, every 6 months, you're going to get a $30 interest payment until the bond matures. The other thing that you need is to know what interest rate you're going to use to find the value of the bond. And the question gives it to you. All right, so it says, what would the value of the bonds be on June 30th, 2018, if interest rates had risen to 12%? Now remember, so part 1, nominal Nominal interest rate equal 12%. Right? Semi-annual the semi-annual interest rate would be what now?
%6%, sir.
Yeah, man. Just like for time value of money, we divide it by 2. So the 12% divided by 2 give us, wait, hold on. Yeah, so 12% divided by 2 give us 6%. So the first thing, one of the things that we need is the interest rate. So we can know we will need to find I, and we use common I for the interest rate, and N. All right, so we need to find both I and N in order to find the bond value. By the way, this up here, when we found the coupon payment, right? The symbols that we use, so I just bringing back the symbols. We said that $I, capital I now. So the dollar value of the interest payment that we get is $30. So capital I with the dollar sign, that's the coupon payment. The common I is the interest rate. So the semi-annual or periodic rate is 6%. Next thing we want to find is N. So N equal number of payments from so number of payments after June 30th, 2018. Now, why do I say after? If you were to buy the bond on June 30th, 2018, that's one of the date that interest is paid. But the person that's going to get that interest payment is the person that owned the bond before you. So when you buy it on June 30th, 2018, you're not going to get that June 30th interest payment. What you're going to get is the next interest payment, which comes 6 months' time, which will be December 31st. Right? So what we're saying is N, and this is common N. So N is the number of payments after that date. Right?
So can you carry up the screen, please?
Yeah, man. That way?
Yes, sir. Thanks.
Yeah. So N is the number of payments that come after June 30th. Bear in mind that the maturity date is, we got that from up top. It was December 31st, 2030. So we're saying, how many payments are we going to get in 2018? Remember, one of them is 2 payments every year, and the first one gone already. How much payments are you getting in 2018?
So one more leave, sir.
One more leave, sir.
Right. So 1 payment for 2018. And then we have now number of payments from 2019 to 2030 when it matures.
Right, 24.
Yeah, but so yes, at 24.
Yes, sir.
Yeah, man, 24 is correct, but let me see if everybody can see the 24 before I discuss it. All right, so the correct answer is 24. But let me see if everybody can see it for themselves.
Yes, sir.
See it?
Yes, sir.
All right, so 2 persons see the light so far. So how many other persons see the light?
Yes, sir. I think I see it. Yeah.
You see it? All right, nice, nice. So, long way is to note 2019, 2020,
Oh, you got
2021.
the 24, sir?
Huh?
Oh, you got the 24?
I'm
Oh.
going to show you now. I'll show you the long way first.
The answer is in the chat.
Yeah, 12 times 22. But I want to show the 12 first. So 2019, 2020, 21. This is what, 6 years, right? Agreed?
Yes, sir.
Then we have 25, 2026, 2027, 2028, 2029, 2030. And that's 6 more years. So we can see that it's 12 years. Everybody see the 12 years, right? Because I just start them out straight up.
Yes, sir.
Yeah, I remember how many payments you get every year?
2.
Right. So 12 years times 2 payments equal 24. Which means we can say N is equal to 25. Because we have the 24 payments from 2019 to 2030 plus the 1 payment from 2018.
Sir, oh, we did get the one again.
Remember? So number of payments during 28. 1. June 30th payment. Gone already. So the only payment left for 2018 is the 1 December. Remember the key thing is number of payments after that date. The date the question gave you, let me just scroll up a bit. The date the question gave us was June 30th.
Yeah, if you check it, you get it because it's 2 times to the year you make payments. So up until June, it would be the first payment, and then from June to December, it would be the second payment.
Right. So the first payment gone already. So we're not getting that. So we're only going to get the second payment for 2018. All right. The other thing, you could have also said, since you already take care of 2018, you could have said 2030 minus 2018 equal 12. Right? But I'm saying because you don't want to make the mistake and give away the marks, because if you put the wrong figure, the answer going to be wrong. Just like I wrote it out here, and you can check it on your finger, even quicker than how I write it. Right? 2019, 20, 21, 22, 23, 24, 25, 26, 27, 28. And we see it's a 2 more leave, 29, 30, 12 years. right? So it's always best to make sure, don't take it for granted. Make sure you have the correct figure for N. If you have the wrong figure for N, your answer going to be wrong, right? So note now, we have N equal 25 and I, the interest rate, is equal to, what was it, 6%, right? Because remember, it's a semi-annual rate. And we had already found from before we looked at part one, we saw that the interest payment was $30 and the par value is equal to 1,000. All right, so I'm going to use the table now to finish this. Right? We already talked about the formula a lot, so I'm not going to go back over the formula now. Right? We know, so sometimes we still need to use the formula, but let me just use the table here. So the approach, we are saying, and the other formula is in the notes, it's in the recorded lecture, the pre-recorded lecture. But watch me now. Bond value is equal to the interest payment times present value interest factor annuity I, comma N plus the par value times present value interest factor, no annuity thing now, just regular interest factor I, comma N. So this is a lump sum table that we're using for the par value, because the par value is just one payment at the end, $1,000 at the end, right? If you're some people, and this is what some people do. Some persons say, all right, they use a formula for the lump sum, but they use the tables for the annuities. All right, just to make sure they don't get the tables mixed up. So those persons only really focusing on the annuity tables, but not worry about that yet. So here we have it. The interest payment is $30 times I is what? I is 6% and it's 25. I'm using the present value annuity table. So 6%, let me bring up my table.
I think it's 12.7834.
All right, I think that sounds correct, but let me just bring it up to make sure. So remember, it's not the future value, not the future value table now. We're using the present value annuity table. So we're using this table, present value annuity. So 6% and N is 25. So 25 is down here. So scroll across to 6. And we get this figure. All right, so 12.7834. Plus the par value now times the present value lump sum figure. So I go into the present value lump sum table now. Scroll up.
4.2919.
I think I hear it's a 12.
No, sir, not 12. 12 would be too much.
Yeah, normal, but it's always going to be just a decimal.
Yes, sir.
So it's yeah, see it here, 2330. So this will always be 0 point something for the lump sum part. Right, the present value lump sum is always 0 point something. So if you have something else, it means you're using the wrong table. All right, so I'm gonna go back to the question. Almost through, guys. Almost through. There with us a little bit more. All right, so this is what we have now. And it's just a little maths now. This part's straightforward. All right, so 30.
Sir, this what you're working out now is section what of the question, sir?
The first part 1.
Sir, it's part 1 is
Yeah, man. Remember, it taking this long because you see all of these things that I'm writing out. It's explanation.
okay.
Right. So most of what we're writing out is just explanation.
Okay.
I'm gonna do part 2 too, and you'll see that it's short. So 30 times 12.7834.
3.502.
How much? Yeah.
83.502.
I can just run it off at 50.
Okay.
It's 383.
Yes, 0.5.
Right, and this one I don't need you don't need a calculator for that one. I'm gonna add these to get what? 6. .50. That's correct.
16.5.
All right. So and you can see that this would be a discount bond because it's less than $1,000. But that's in the notes still. So I'm not going to focus on that now. So the bond value here is 616.50. All right. So on gone, I'm a news time, you know. All right. Then we run through part 2 quick. All right. So part 2 is a similar question. Right? It says different date. So the date now is December 31st, 2022. And interest rate is 4%. I remember, so we always divide that by 2. So we know so that's going to be 2%, right? So let's find N. For part 2. So we already said I, the interest rate is equal to 4% divided by 2, 2%. So N equal number of payments after December 31st, 2022. I remember maturity date equal December 31st, 2030. Make sure, yeah. So what is N in this case?
Sir, before I said 9, but when I'm looking at it now, we would include the 2022 because it's saying after, right?
Yeah, wouldn't include it.
Right, so it would be 8 then.
Right, yeah, man. I remember we always multiply by 2. So it's 8 years worth of payments, 2 payments every year. Right, so remember, it's after December 2022. So you're not going to get a payment for December 2022. Your first payment will be 2023. So it's really 2023 up to so from 2023 to 2030 is 8 years. I'm gonna put this at the end. Right, from 2023 to 2030 is 8 years. I'm getting 2 payments every year, so it's 8 times 2, 16. Right, once you have that, just drop the information in the formula. So the payment, we said that not changing, is always 30. So 30 times, I'm looking for 2% with n equals 16. How much?
18.6393.
No. Not sure you get that 18 from at
No,
all.
wrong table, sir. It's the present value I should be using, not the
Ah,
Sorry about that.
yeah, man.
So it should present value 2% for 16, 13.5777.
Right. So that mistake, get it out
Yes.
existing very quick here.
Okay.
Wrong table mistakes is a costly mistake. And for the other one is 0.7284.
284.
Yeah. Nikita Dean, why are you writing on my board?
Sorry, sir. Sorry.
It's all right, man. You're good. You're good. So multiply this one for me, though.
407.33.
4
407.33.
plus 72840. 1,130.
35.73.
Yep. So you realize now that this is really the working that you need, apart from the dollar I. So everything else that I was showing you was just explanation. So it's not really a long question. It's just that you have to understand what you're doing. The last thing is I'm not going to go through that now because I want to get some of the news. But so the rest of this we can look on the tutorial sessions. But the key principles that we wanted to go through is how to find n correctly, how to correctly find n, and how to correctly find I. The other part of the question is asking you for the yield to maturity. That's another formula that is on the slide. Not a difficult formula either, but what's difficult and what people have a problem with, people have a major problem correctly calculating n, especially n. People also have a problem remembering that they need to divide the rate here. So the rate for this rate, the interest rate, they need to divide it by 2. People, and the 4% divide by 2. People keep on forgetting that too. Right, so those things I wanted to reinforce. All right, the rest of it, tutorial sessions, will take care of that. All right, so we're going to do another class like this, but not next week. Next week is a test. The following week, we have another class like this based on the topics that we have at that point. So by then, we should have done, where's that? Well, we see. I don't remember which topic coming next, but we will see. So not next week, guys, but we're going to have another Sunday class like this the following week. All right, so I'm going to end this now. And you
Sir, you
guys,
can carry down the sheet, please.
so I carried on it
Yes, sir.
here.
Yes, sir.
All right.
So, do you have any issues sharing this document with us?
This one, yeah, I can put it in short, yeah. Not an issue.
All right, so do that for now, please. Thanks.
All right, yeah, man.
Where you say you're going to put it there?
I'll put it in the WhatsApp group.
Okay, thanks.
Yeah, man.
Ah.
Yeah, what you want, you have to ask for it. The words you can hear is no.
So that's why I'm asking.
All right, cool. Let me just save it from now so that I don't forget.
So can you clear up the screen for me, please?
All right. Wait. Sorry, here or no? Sorry. Who asking? Sorry. Look for it in the WhatsApp group in the next 5 minutes.
All right, sir. Thanks.
I'm going to watch news now, so I'm going to leave it. I'm going to shut down. But look for this in the WhatsApp group. No, I'm going to just save it and put it straight to the WhatsApp group.
Thanks again.
Okay, sir. Thank you.
Yeah, man, take care, guys.